Hello, I'm Dave Tegeder, and welcome back to part 2 of the Soy Excellence Center's educational series on Ohio Lake soybeans and oil. Today's presentation will focus on sourcing Ohio Lake soy products and their supply chain considerations. In this presentation, I'll cover the types of identity-preserved supply chains, key steps in contracting and purchasing, similarities and differences to commodity soy, why forward contracting is necessary, and the timeline involved with IP programs, quantifying Ohio Lake soy's value along with pricing considerations, documentation and inspection requirements, delivery and storage considerations, sources of Ohio Lake soy products, and finally, I'll wrap up with a brief summary. Recapping what was covered in Part 1, U.S.-produced Ohio Lake soybeans are a major crop innovation that brings consumer health benefits and improved oil functionality for both food and non-food industries, and are now being grown and marketed through identity-preserved, often referred to as IP supply chains. However, when sourcing from IP supply chains, there are differences when compared to commodity soy purchasing and handling procedures. The information I'll be discussing today is intended to provide you with a basic overview of the key steps in developing simple and cost-effective Ohio Lake soy supply chains. Let's begin by learning about and understanding the different types of identity-preserved supply chains. You may have heard of the phrase farm to fork, but when we look at the supply chain for Ohio Lake soy, we're really talking even before the farm. It actually begins with the specific traits seed technology developer, such as Corteva or Missouri Soy, who then can either commercialize it through its own seed distribution center or license the trait to a third-party seed company, who would then integrate the trait into its own soybean product lines to then be sold to farmers. Once the crop is harvested, the grower can then either deliver directly to the contracted processor or grain company's elevator, who stores the crop for later delivery to a licensed processor or contracted export customer. But ultimately, the Ohio Lake soybeans are crushed, and the refined oil and protein meal are sold into their targeted markets, where the real value is captured. So when we define identity preservation, or IP, we're talking about the handling processes in all the steps of the supply chain that prevents the mixing of Ohio Lake soybeans or oil with their commodity counterparts, from seed to harvest and storage, processing, and transportation to the final customer. The IP goal is to protect the purity or value and maximize the volume of Ohio Lake soybeans and oil by avoiding leakage into and mixing with lower value commodity soybeans. The key elements and steps in an effective IP system include identification of critical control points and actions for each supply chain participant, development of actions needed for each control point, establishing performance standards and metrics to measure effectiveness, measurement tools to enforce the standards, and finally, a fair system of economic incentives to reward successful performance. There are two basic types of IP systems used in commercial grain production, commonly referred to as either soft or hard IP. Hard IP systems are used with non-GMO certification and require more complex grain production and handling protocols for farmers, grain handlers, and processors. This involves extensive testing and using sensitive PCR assays to detect the presence of GMO grains or oilseeds, as the specifications and contamination tolerances are often defined in parts per million. Soft IP is used when supply chain tolerances are not as strict as those for non-GMO certification, while still providing for appropriate segregation protocols to preserve the value and maintain higher quality. Soft IP is less complicated and less costly, while still using quality testing to monitor adherence to contractual specifications. The tolerances for farmers are significantly less stringent and often expressed in whole percentages rather than parts per million when measuring contamination. Currently, the vast majority of high oleic soybeans are produced using a soft IP system. However, I would point out that the non-GMO high oleic varieties would likely maintain hard IP systems in order to meet the non-GMO certification requirements. When we look and talk about high oleic soy supply chains, the entire U.S. soybean industry and stakeholders are engaged, including its affiliated trade associations such as the United Soybean Board, Qualisoy, and USSEC. For seed companies, that means providing high-yielding seed products that are adapted for specific production areas and that deliver a consistent fatty acid profile over multiple growing seasons, while also providing a good balance between the soybean's protein and oil content. They're also responsible for securing global regulatory approvals as needed and ultimately providing adequate seed supply and distribution to contract growers in order to meet demand. Farmers commit to contract high oleic soybeans for a licensed processor or exporter that specifies IP requirements, delivery terms, and grain quality standards. They also evaluate high oleic seed variety performance data to ensure they meet the farmer's expectations for yield and agronomics. They then place their seed order, which is usually about 6 months prior to actual planting, in order to assure availability. During planting, they need to clean out their planters to avoid mixing with commodity soybean seed and plant in dedicated fields with soils that optimize the seed genetics. They also clean the harvest and soybean transport equipment to avoid commingling and arrange storage in their on-farm cleaned and dedicated bins or deliver directly to contracted processor or exporters. High oleic soybeans are tested at each delivery location to assure fatty acid specifications, specifically the oleic and linolenic acid content, and other quality factors are met. Any loads that are rejected are sold as commodity soybeans and do not earn the grower premium. And finally, the high oleic grower premium is paid to the farmer by either the processor or exporter at contract fulfillment. Engagement by licensed processors and exporters includes securing end-user commitments, usually by September prior to commercial production, in order to estimate the number of contract acres needed to satisfy demand. They then determine the desired production locations along with the specific seed brand in order to establish the final oil specifications and coordinate with the seed company to assure supply. They're also responsible for recruiting growers, establishing the grower premiums and IP requirements, and secure sufficient grower contract agreements for their estimated demand. They also arrange for a network of country elevators to aggregate the IP soybean production volumes and to provide convenient farmer delivery locations. They manage the scheduling of whole soybean deliveries to coincide with either crush runs or export shipments. They test all inbound loads of soybeans for fatty acid along with usual grain quality factors. And finally, they manage IP protocols for shipping and handling of high oleic soybeans and/or oil. Importers and refiners are responsible for securing high oleic soy product samples in order to evaluate functionality values with their end-use customers prior to entering contract negotiations. They then determine the fatty acid and oil quality specification requirements based on the functionality needs of their end-use customers. They plan for delivery timelines based on IP production requirements, and evaluate and select suppliers from participating U.S. seed developers, processors, and soybean exporters. They also specify the high oleic soybean trait that will best meet their customers' requirements. They confirm pricing and delivery timelines and fatty acid specification commitments with their U.S. suppliers, and determine proper IP requirements for inbound handling and processing procedures, in addition to training employees on the proper IP protocols and implementation. Finally, they receive the whole soybean and/or oil shipments and maintain IP protocols during all handling and processing. I'll next discuss contracting and the key steps involved with purchasing high oleic soybeans and oil. Here are some of the key items to clarify with high oleic soy suppliers during negotiations. First, it's important to determine which high oleic soy trait they're marketing, along with determining the specific fatty acid content being offered, such as the minimum oleic acid or maximum linolenic acid levels. For whole soybeans, will oil and protein content be similar to that of commodity soybeans? You will also want to clarify the type of testing methodology to be used for fatty acid specifications. For whole soybeans, will it be via NIR or near infrared technology, or by wet chemistry using gas liquid chromatography, or GLC? For oil, it will always be with GLC analysis. Remember, there is no standard contract for purchasing high oleic soybeans or oil because of the unique IP supply chains and more detailed specifications. Key purchasing steps include determining the required high oleic oil specifications needed for your country's markets, including the fatty acid profile components to be included in the contract, and whether the trait can be a biotech or GM product, or does it need to be a non-GMO. Once those factors are known, you can then determine which suppliers can provide the appropriate high oleic soybeans or oil. Remember, not all U.S. soybean exporters or processors are engaged in high oleic soy supply chains or geared towards the export market, but your local USSEC staff can provide you guidance on current suppliers suited to your individual needs. Before purchasing, you will want to request a sample of either the whole high oleic soybeans or oil from the specific supplier you're considering. It's important to get a representative sample of the supplier's high oleic product offering, as there can be variances in the fatty acid profiles between different supply chains. A given geographical growing region may also slightly affect the fatty acid profile. The next step to initiate supply and pricing discussions with the potential suppliers and determine lead times required for the quantity and delivery periods needed. You may also want to assess the level of technical support a supplier can provide to help your company facilitate application testing and market development if needed. You're then ready to negotiate the final contract and agree upon the final fatty acid specifications to be included and agree on the analytical method to be used for official sample analysis. In the case of whole high oleic soybeans, if the buyer intends to use NIR quick testing at its inbound facilities, they should ask the supplier to provide the appropriate NIR calibrations to assure accurate fatty acid determination. Turning now to the similarities and differences to commodity soy. For similarities, they're traded under the normal governing soybean or oil contractual terms, priced in the same manner off the Chicago Mercantile Exchange futures, and can use the same risk management tools. In addition, the high oleic premium basis can be contracted in advance with the final flat price established prior to delivery. The same USDA Federal Grain Inspection Service soybean standards apply, and the same American Oil Chemists Society's test methodologies are valid for refined oil analysis. The same freight channels can be used for commercial shipments, and for processing, there is no difference in either mechanical or solvent extraction characteristics. The resulting protein meal's amino acid profile will be the same, and for documentation, the same harmonized system codes can be used for customs declaration. For differences to commodity soy, they are specific to a given seed technology company's trait, with defined growing regions for each supply chain and grown under soft IP guidelines. This means there are segregation requirements to prevent commingling and isolation throughout the handling, shipping, and receiving process. There's also a few more details to be specified for high oleic contracts that will be included in contract negotiations. Determination of high oleic soy premium over commodity soy is primarily based on IP costs, and there are longer timeline considerations when purchasing larger volume commitments with a specific supply chain partner. Similarities of high oleic to commodity soybean oil include normal refining characteristics, the same phospholipid and lecithin content, and the total tocopherol content and specific types of tocopherols present. Differences include an improved lecithin stability and iodine value, which measures the degree of unsaturation. Commodity soy, which is primarily composed of polyunsaturated fats, typically has an IV value of 120 to 143, whereas high oleic soy, with its high amount of monounsaturated fat, will have a lower IV value between 75 to 105. And the cold temperature properties of high oleic soybean oil may need some management. High oleic soybean oil, with its significantly different unsaturated fatty acid profile, results in a change in handling characteristics when exposed to lower temperatures for prolonged periods of time. If you're familiar with olive oil, then the handling characteristics will be very similar. Since oleic acid has a lower melt point, congealing and solidification might occur with bulk high oleic soybean oil during the transport or in storage tanks when located in colder climates. High oleic soybean oil will meet the standard 5.5-hour minimum cold test that's typical for most salad oils, but exposure to near freezing or lower temperatures for greater periods will result in viscosity increases beginning around minus 10 degrees Celsius, with solidification onset at minus 16 to minus 23 C. High oleic soybean oil, however, will return to its liquid state once warmed above freezing. So it's recommended to use heated or insulated tanks and heat-traced external pipes if buyers anticipate exposure to prolonged freezing temperatures. It's very important to understand that forward contracting is necessary to assure availability for your high oleic soy commercial volume needs. High oleic soy is still in early stages of commercialization relative to commodity soy or other oilseeds. The increasing demand we're also seeing for high oleic soy has resulted in limited amounts of uncommitted supplies available for immediate sale and nearby shipment. Suppliers will certainly be able to provide you with sample and smaller amounts sufficient for lab or pilot plant testing, but large commercial quantities will need to be forward contracted in order for suppliers to coordinate the required identity-preserved production all the way back to the farm. To give you a better understanding of why this is so important, I've mapped out the timeline for contract production that will supply the 2023 marketing year. In January, seed companies will finalize their plans for the total quantity of high oleic seed beans needed for the 2022 crop, along with the appropriate maturity types needed for where they will be grown. Remember, soybeans are sensitive to the length of the growing season, so varieties suitable for Minnesota or Iowa need to mature during a much shorter growing season relative to varieties developed for more southern regions. They're then planted this spring and would become the high oleic seed beans planted the following year. By midsummer, suppliers will be finalizing their plans for the amount of high oleic soy they would like to have available for 2023. Each supplier then determines how many acres they need to contract for the 2022 crop. They then establish acreage targets with the respective seed companies for each geographical area where they want them grown. In August, the seed companies' field teams begin their fall sales programs and proceed to sign up farmers for the amount of high oleic acres they intend to contract for delivery to a specific supplier's location. It's important to also understand that the majority of farmers buy their next year's seed needs before the end of this year. The 2022 crop gets planted and harvested that fall. This new crop supplies either the whole high oleic soybeans or processed oil that will be available to buyers throughout 2023. So hopefully you now understand why it's important for interested buyers to be in purchasing discussions with U.S. suppliers roughly 18 months in advance of when high oleic soy products are needed to assure their availability. I'll next go through quantifying the value of high oleic soy, along with some pricing examples. As you learned in part 1, it's the performance advantages of high oleic soybean oil that equate to increased value. It's healthier, provides a cleaner, lighter flavor, provides an excellent OSI score, which equates to up to 2 to 3 times longer fry life, up to 3 times longer shelf life in packaged foods, a higher smoke point, easier cleaning, and allows for simpler ingredient labels by enabling the removal of synthetic antioxidants. For this year's crop, licensed suppliers are paying farmers between 40 to 80 cents per bushel to contract grow high oleic soybeans. At 11.4 pounds of oil per bushel, this translates into 3.5 to 7 cents per pound in the resulting high oleic soy oils price. And I will point out that the soybean industry anticipates the grower premiums to decline over time as volume increases. You then need to account for the processor or exporter's profit margin and costs for segregating the high oleic beans and or oil, in addition to their marketing costs. These too should decline over time as economies of scale are attained. So we are currently seeing the U.S. market premium for high oleic soybean oil around 10 to 15 cents per pound over that of commodity soybean oil. And I should point out, this is assuming high oleic seed varieties with yields equivalent to commodity soybean varieties. Any high oleic soybean traits with significantly lower yields would likely have a resulting higher premium. So let's run through what a high oleic soy pricing example would look like. And to keep it simple, I'm not using any commodity soybean basis for either the whole beans or oil. But keep in mind, in the real world, those levels would have to be added into the calculation. When we add together the grower premium, royalty back to the trait developer, and elevator handling fees, the resulting high oleic premium on whole soybeans would be around 75 cents per bushel, in addition to the commodity soybean basis. For the high oleic soybean oil, the premium would be around 15 cents per pound, in addition to that of commodity soybean oil. You would then add the net high oleic basis to the respective Chicago Mercantile Exchange futures prices. At the time of this example in September 2020, I'm using futures prices of $10.25 per bushel for nearby soybeans and 34 cents per pound for soybean oil. This would result in $11 per bushel flat price for high oleic whole soybeans and 49 cents a pound for high oleic soybean oil. Converting these prices, we get approximately $404 a metric ton for the high oleic soybeans and $1,080 a metric ton for the high oleic soybean oil. Of course, if you are buying high oleic soybean oil from a vertically integrated processor refiner, they in turn are in the business of making a profit. So purchasing whole high oleic soybeans to crush at your own facility would result in a lower overall high oleic premium. In this example, I'll just convert the whole high oleic soybean premium I used previously into a resulting oil premium. So starting with the 75 cents per bushel for the high oleic whole soybean premium, this equates to about $28 per metric ton. Now using a 19% oil content, 1 metric ton of beans would yield about 419 pounds of oil. This would equate to about 6.5 cents per pound or $145 per metric ton as the high oleic premium for the resulting oil. So, if you can crush and refine, the cheaper route will always be to purchase whole high oleic soybeans. I'll next go over some of the documentation and inspection requirements with high oleic soy under soft IP systems. As I mentioned earlier, the focus for identity preservation with high oleic soybeans and oil is to protect its value and maximize volume by avoiding any mixing with lower valued commodity soybeans and oil. Buyers should receive the proper certificates of analysis that verifies shipments are within contractual specifications. For whole high oleic soybeans, NIR is a quick and reliable method to check the oleic and linolenic fatty acid content along with protein and oil. It's also important to verify with your high oleic suppliers that the supplied NIR calibration software was developed to accurately measure the specific high oleic trait being tested. For oil, gas liquid chromatography, or GLC, is the most widely used and accepted test procedure to determine the fatty acid composition of a given oil sample. In the next few slides, I'll discuss delivery and storage considerations. When we look at the various means for delivery options for high oleic soybeans or oil, they're going to be very similar to those used for importing commodity beans or oil. The high oleic soy market is not as mature, however, so initial delivery modes might need to accommodate smaller quantities. A buyer's limited ability to segregate their on-site storage, along with uncertain initial demand, might also be a good reason to initially contract smaller quantities. Types of delivery modes for high oleic soybeans might include 20-foot equivalent unit containers, jumbo hopper cars, barges, all the way up to bulk vessels. For high oleic soybean oil, this might include food-grade flexi tanks for ISO 20-foot containers, which hold approximately 22,000 or 24,000 liters. They also offer the option of using a steam heating pad if shipping into colder locations. Flexi tanks are more economical than ISO tanks and provide a one-time use, which is ideal with shipping containers. Jumbo tank cars that are exterior coiled and insulated may also be used if rail delivery is an option, along with liquid barges and ocean-going vessels. Smaller options for pilot testing might include collapsible totes and steel or plastic food-grade drums. A good point to remember regarding IP considerations is that for every 10% contamination of 75% high oleic soybeans with commodity soybeans, the resulting oil's oleic content from the commingling would drop to 70%, negatively impacting the oil's functionality. So the primary goal is to minimize commingling with commodity soybeans. The tolerance, as noted above, is significantly higher than that of non-GMO beans, where contamination is detected in parts per million. High oleic IP requirements are actually similar to other IP crops, such as white corn, and less stringent than non-GMO contracts. Simple clean-out procedures at planting, harvest, storage, and transport can all help maintain a high level of purity with high oleic beans. And quick NIR tests at delivery locations can verify shipments meet the minimum standards. When importing whole high oleic soybeans, it's important and recommended to conduct employee training so they understand the need for IP protocols. These may include utilizing storage facilities, dump pits, or grain legs that are not shared with other grains or oilseeds at the time of high oleic soybean deliveries. Be sure to clean out or use dedicated pits, legs, and grain conveyance, and prior to delivery, verify that the storage bins have been swept out and visually inspected to verify they're free from any seed. It's also good to visually inspect the trucks used for transport are clean before hauling any high oleic soybeans. And for quality control, test a sample of each load prior to discharge with NIR for its oleic and linolenic content. Suggested IP guidelines when crushing to assure oil purity once again includes employee training and determining if the crush plant will either shut down and clean out at the beginning and end of each high oleic crush run, or begin the high oleic crush run without shutting down, or as we refer, on the fly, during which the crude oil would be tested routinely to determine when to divert into a dedicated high oleic soybean oil tank. However, by doing this, there is the potential to lose more of the high oleic product during the initial flush periods. And of course, test the crude oil on a scheduled basis throughout the processing run to document the oil purity. Refining considerations are going to be very similar when changing over to a different vegetable oil through the refinery. Suggested guidelines include employee training, purging all process oil lines ahead of high oleic soybean oil conveyance, use appropriate means to segregate the oil through the refinery, verify the dedicated tanks are empty and clean prior to use, purge lines from the finished fully refined oil tanks to loadout, and verify that each tank truck or mode of finished oil shipment has provided a wash certificate and has been visually inspected prior to loading. Storage of fully refined high oleic soy oil follows similar guidelines as that of commodity soybean oil and should have at least a minimum of a 1 year shelf life, assuming that the oil is not exposed to extreme heat and ideally stored at ambient room temperature or cooler. Limit the air exposure during storage by sparging the headspace with inert nitrogen gas. Limit the oil's exposure to light. Avoid contact with reactive metals such as copper. And finally, avoid any contact with moisture while in store. Turning now to sources of U.S. high oleic soybeans and oil. As I discussed in part 1, there are currently 3 different high oleic soybean traits in various stages of commercial development and availability. When they all have an oleic content in the mid to upper 70% range, there are slight variations in the rest of their fatty acid profiles, along with different seed technologies used in their development. Corteva Agriscience's Plenish trait, marketed under its Pioneer seed brand, was developed using biotechnology and is the most widely grown and commercially available at this time. Missouri Soy's trait, called Soylaic, is a non-GMO, but it has a slightly wider variation in its fatty acid profile and is just starting to be commercially grown. Calixt's Calino trait was developed through genome editing, but it is only being targeted for use in the domestic market at this time. So the U.S. soy industry has high oleic varieties suited to whichever attributes your customers value the most. Current suppliers of high oleic soy include most of the top soy processing companies, including ADM, AGP, Bunge, CHS, and Purdue Agribusiness. Packaged high oleic soy oil is available from oil companies such as Catania, Stratus, and Ventura Foods, who offer either a 100% high oleic soybean oil or as a blend. You can also source samples of whole soybeans and or oil directly from the trait developers such as Corteva and Missouri Soy, and regional grain companies such as Benson Hill, Brushvale Seed, Central Valley Ag, Clarkson Grain, DeLong, Landis Co-op, and Schooler are all interested in pursuing future contract acreage programs to supply whole high oleic soybeans for international customers. Your local USSEC representative can help you contact the appropriate suppliers for your individual needs. High oleic soybeans are currently being grown across the major soy-producing states in the U.S., stretching from Nebraska in the west to Maryland in the east. For the 2020 crop, there were approximately 500,000 planted acres, and forecast to increase to up to 900,000 acres in the next few growing seasons. As I mentioned earlier, the majority of high oleic soy suppliers are currently offering the Plenish trait, as you can see by this list of current suppliers and the seed traits they're marketing. As with any new crop, however, this list is dynamic, so once again, your local USSEC representative can help you with finding the best supplier for your needs. So, to summarize what I have discussed in this series, high oleic soybean oil is bringing valuable benefits to both food companies and consumers. The identity preservation supply chain system assures high product quality and maximizes value, but it does have differences from commodity soybean procurement. High oleic soybeans and oil are now available from U.S. suppliers, and samples can be provided to help you quantify your added value opportunity. And USSEC staff and consultants are ready to help establish your supplier contacts and advise on supply chain management issues. Here's a list of some conversion factors for you that are useful to have on hand. You can also find additional high oleic soy information on the QualiSoy and USSEC websites. Much of the information that I covered in this presentation is available in the U.S. High Oleic Sourcing Guide that's available now from your local USSEC representative. And I have finally provided a QR code that you can scan, if you desire, to directly import my V-Card contact information. Thank you for your time and attention, and I hope you now have a better understanding why high oleic soy is such an exciting new product brought to you by the U.S. soybean industry.